Assalamualaikum. I am Raji Akhtar Srishti. My ID is 2411508 Today we are presenting about error detection. Today we are talking about introduction, types of error, redundancy, Hamming distance, CRC, polynomial representation, CRC, checksums and complementary checksum, priority check, blocking, coding basics and conclusion. Meet our teammate Tilok Paul, Jahidul Islam Rimon, Mubarak Himo, Rishadul Islam. Introduction. When we send data from one device to another device, it can get damaged. So we use the error detection to check if the data is correct or not. So today I will explain some different types of errors and methods to detect them. Types of error. There are two types of error: single bit error and burst error. Single bit errors happen when one bit is changes either from 0 to 1 or 1 to 0. It also easy to detect and fix them. Burst error. Burst error happens when several of bits changes. Also, it is very difficult to detect and very difficult to fix the errors. Thank you. Now I will call my next team member to discuss the next part.
Thank you, sir, for giving us the opportunity to present before you. This is Tilok Pal. Last 3 digit of my ID is 690. Let's talk about redundancy. Redundancy is not technique of error detection. It is a concept used by this technique. Redundancy means adding extra bit to our existing message and to detect errors. Like if it is our message, then adding extra bit to our existing message is redundancy. It's like a message with seal on it. If the message is sent to the receiver checks the seal is broken or not. If the seal is broken, that means that a message is corrupted and request it again. If the seal is not broken or the remains same, then the message is not corrupted. Checksum is a error detection technique. We can check error in any length of message. If the message is this long, we will divide into m bits. Message into m bits. Then, and if the m bit message is 2463, then the checksum will be the sum of the total, which will be 15. And if this checksum is added to existing m bit and sent to the receiver and added all the m bits and matched to the checksum. If the checksum in the receiver end matches the sender end, then the message has no error. It is the comparing two checksum is hard, so we can do one simple thing. We can push complement the checksum. Then the sum will be sum of the total message is become 0 and sent to the receiver and receiver end will added all the sum, and if the result becomes 0, then the message has no error. If the message is message results sum of the message is not 0, then the message has error and request for another message. There is a problem with our checksum technique. So here the complementary checksum introduced. In checksum, the total sum is always greater than the m bits, all m bits. If here 12 in binary, P is 1100, which is 4 bit, but the checksum, the total sum is 6 bit. So we need to convert this 6 bit into 4 bit. How we can do this? We can add first 2 bits to the existing message, existing 4 bits, and get a binary bit. This is our word message. If we implement this word message, we get our checksum and sent to the receiver end, which is 9. And receiver end, same process happen, and the 45 in binary is 1 1 1 0 1 1 0 1. The first 2 bits is added to the 4 bits and become 15. If we want to complement it we get our checksum. If the checksum is 0, then the message is not corrupted. If the checksum is not 0, then the message is corrupted.
Hello everyone, Assalamu alaikum. Thank you for giving me this opportunity to present myself. I am MD Jahidul Islam Limon, ID 24 Today I'll discuss about Hamming distance. For determine Hamming distance, the number of distance between the corresponding bind of odds. For example, we can see that if the code word is 0000 and for sender and the receiver is 0101, then we can find the distance equal 0. Why? Because we can see here 0 is replaced by 1 and here 0 is replaced by 1 and also here in 0 is replaced by 1. So we can see that there are 3 differences between the sender and receiver. That's why the distance is 3. We can also find the distance by number of ones in XOR result. For finding minimum Hamming distance, the smallest Hamming distance among all code words. For example, to detect S errors, we can see the formula is D minimum equal S plus 1. For higher distance, better error detection or correction capability. In priority check, if we add 1 byte for every unit, so that the total number of on is even for even priority and odd is for odd priority. In two-dimensional priority includes error detection beyond single priority. Thank you.
Assalamualaikum. This is me Janati Humaira Akhtar Himu and my last 3 digit is 738. Now I will explain CRC, which stands for Cyclic Redundancy Check. CRC is a very strong and popular method used to check if data has any errors. The idea is very simple. First, the CRC uses binary division, and that means we divided the data using a special number called a generator polynomial. Then the sender sent the data, and they divided the data by his polynomial and get a remainder. And this remainder is called the CRC bits, and it added to the end of the data before sending. Then the receiver gets the message and divided the whole things again with the same polynomial. If the remainder becomes 0, it means data correct and no errors has happened. CRC polynomial representation. CRC works with bits, but we can also think about these bits as polynomials. For example, if we have 1101, we can write it x cube plus x square plus 0x plus 1. CRC uses a special type of division called polynomial division, which basically means we divided without any carry or borrow. Thank you.
Assalamualaikum everyone, my name is Rishidul Islam. My ID's last digit is 166. Today I am presenting block coding basics. First of all, receiver knows valid code words. The receiver has to know the valid code words so that when it is something invalid comes, it can detect it and it can change it in time. Now, in the code word, if there is something little bit change, it can make a bigger change and the whole code word can be invalid. So we have to keep a look at it. Then small bit changes usually produces an invalid code word, allowing easy error detection. Here comes the Hamming. Hamming code word is actually when there is something a little bit difference between two code words. The big distance is easy to detect the invalid ones. Then larger Hamming distance improve multi-bit error detection. Always, if the bit between two code words is the same, the multi-bit difference error detection is really easy with Hamming distance. Now, the conclusion: error detection ensures between data transmission if